For today's video, we will answer a math challenge given by one of our followers. And his question goes like this. Given that x is a real number, then our goal is to solve for the value of x given this equation 5 raised to the power of x plus 25 raised to the power of x equals 50. Now you can pause this video if you want to give this problem a try. Now suppose you pause this video. Now let's see if you got the correct answer. Alright, so given this equation, our goal is to solve for the real value of x that satisfies this equation 5 raised to x plus 25 raised to the power of x equals 50. Now, one thing to notice in this equation is this 25, because this 25 is just 5 raised to the power of 2. So we can replace this 25 with 5 raised to the power of 2 like this. Now at this point, in this term, we will use some laws of exponent. Now take note, when we have b raised to the power of a raised to the power of c, we can write this as b raised to the power of c raised to the power of a, or we can interchange this c and a. Therefore, this term, we can rewrite this as 5 raised to the power of x raised to the power of 2. Now the question is why we do that? Because we have a common term of 5 raised to the power of x. Now, if we have a common term, we need to replace this, or one strategy is to replace this with another variable, and let's call this as t. So let 5 raised to the power of x be equal to t. So all 5 raised to the power of x becomes t, or we can replace this with t. Now we have t plus t squared equals 50, and this is a quadratic equation. So now let's rearrange some terms a little bit and equate this to 0. Now, this is not factorable. This equation is not factorable. So we will use the quadratic formula. Now, in this quadratic formula, we have t equals negative b plus or minus square root of b squared minus 4ac all over 2a. Now, the question is, what is the value of a? In this equation, it is the coefficient of t squared, which is 1. And b is the coefficient of t, which is also 1. And this c is the constant term, which is equal to negative 50. Now, let's replace all a with 1. And then all b, all this variable b, again with 1. And finally, this variable c, let's replace this with negative 50. Now, let's simplify. 1 squared is simply equal to 1. And the negative 4 multiplied by negative 50 is positive 200. And 1 plus 200 will give us 201. Now, technically speaking, this is the value of t. But take note that t is also equivalent to 5 raised to the power of x, wherein this function, the range of this function is from 0 to positive infinity, so it cannot be a negative number. Therefore, t cannot be a negative number. Therefore, we disregard the negative value of t and we accept the positive value of t. Now, we don't want the value of t, but we want the value of x. So what we're going to do is to equate this. So we have 5x. This 5x is equivalent to negative 1 plus square root of 201 all over 2. And now, our goal is to solve for the value of this x. And to do that, let's get the logarithm to the base of 5 of both sides. Now, here's the purpose why we choose base 5. Alright, first thing, let's use some laws of logarithm or some properties of logarithm. So if we have logarithm of a raised to the power of c to the base of b, we can rewrite this in the form of c multiplied by logarithm of a to the base of b. So we can pull out this exponent c and put this in the front like this. Now, here's a simple property of logarithm. If we have logarithm of b to the base of b, we have the same number. It must be equal to 1. So, logarithm of 5 to the base of 5 is just 1, or simply equal to just x. And there you go. That is the value, the real value of x that satisfies this equation. Therefore, given this equation 5 raised to the power of x plus 25 raised to the power of x equals 50, then the only real value of x that satisfies this equation must be equal to logarithm of negative 1 plus square root of 201 all over 2 to the base of 5. And as always, we are done.